Hi, I'm Krishna. This is day 24 of 30 days of understanding the modern AI stack. So, this video is not theory. This is a walkthrough of a real agent I have been building for the last 1 or 2 days. And honestly, this is the closest I have felt to actually understanding how these modern agentic systems work under the hood. So, let's walk through it. So, see, the agent I'm building is basically I speak and it wakes up, understands the command, call the right tool, and get the result, and thinks again and gives the final answer. A small personal assistant with speech to text, tool calling, multi step reasoning, and workspace memory, screenshot capability, file creation editing, weather search, deep research, and working across Gemini, Groq, and Llama. Not perfect, but definitely agentic. So I have two core files. One is RealtimeSTT.py. It's the brain file, the main agentic file. And another one is tools.py. The brain decides what to do, and tools.py actually does the doing. So let's break it down. So the entry point is the voice listener. I'm using audio to text recorder from RealtimeSTT. I'll add all the links in the description. So this thing listens continuously, detect when I speak, transcribes it, and then passes the text to process text. So my agent doesn't require me to type, it reacts to my voice. Next is tools. So everything the agent can do lives inside this tools.py, whether screenshots, creating file, editing files, deep research using Tavily. You can check it out too. Running terminal commands, typing text, notes, memory system, everything. These tools are dynamically converted into Gemini compatible function declarations through this block in my agentic file. Let me show you. So here's the command in my main agent file, which means Gemini learns the schema directly from my Python functions. This is extremely powerful, and I didn't rely on one model. Like you can see, I had three modes: Gemini and Groq and local Llama running Llama 3.2, 3 billion parameters. If Gemini rate limits or fails, it auto falls back to Groq, but there are some problems. I need to fix it. Like it's not falling back to some other. I have to set it manually. And if Groq fails, it falls back to it. It is supposed to fall back to local. It is showing the logs, but it is not falling back to it. So I'll look into it. So this is how real agent stacks work. Robust and fault tolerant. So all messages are stored in conversation history. It's pruned to maintain stability. We keep the system prompt plus last few messages. Every message is augmented with the agent's current workspace. So the model knows what files exist before choosing actions. And this is the part that made everything click for me. It's a 5-step thinking loop. So first step in range 5 and message brain name. We are getting response from the other function. We are getting from basically from the models we have, whatever we have chosen or set manually. So each response is inspected. If it's a tool call, execute tool, send back observation. If it's hallucinated JSON, sanitization layer fixes it. If it's a final answer, show output and loop. If it's a final answer, show output and stop. This loop is basically think, act, observe, think, and answer. Like the same we talked about in the earlier videos. So this is the heart of React, LangGraph, Devin, and OpenAI agent systems. Once you build it, you'll start seeing the patterns behind all professional agents. And I created a dedicated folder. Like it will create a dedicated folder, agent workspace, if it finds nothing. So the agent can create files, edit files, append to files, list files, run code inside them. This makes the agent feel like it has its own environment. And it also has a capability to take screenshots and save them in screenshots folder. It can also fetch live feather using a wttr.in. So yeah, this guy's just curl, and because that API hates normal Python user agents, this little details make tool-based agent feel real. And I also tried Gemini Live first. It was beautiful on paper, but slow streaming, audio device conflicts, rate limits, output input channel mismatch, because I was using the wrong way. In another one, it worked well, but latency I was getting with the live voice, but it was good. Like in this version, we don't have the response back in voice form. We're just doing the thing and outputting the text in the terminal. So instead of Gemini Live, I switched to simpler architecture using RealtimeSTT for audio and Gemini, Groq, or Llama for reasoning. That's how engineering works now. Find the path that works now and improve later. Building this made me understand that tools must have strict schemas. Agents need structured loops. Fallback models matter. Workspace awareness matters. Hallucination Shielding is crucial. Voice activation is messy, but yeah, I'll figure it out eventually. Diagrams like code teaches. Agents are not magic, just loops plus tools. Later, I'll hook social media, emails, calendar, just like OpenClaw. Just trying to do something like the guy did, OpenClaw guy did. Some automation task, maybe even screen navigation. Yeah, I'll try. Basically, why mini version of OpenClaw, totally under my control. Yeah, I'll try if I get time to do it. So let me now show you how it works. Like we run the commands. Let us now run the program and we'll test all the tools we have. So we have this thing on our computer to turn off the mic. Hello, hello. Can't listen because I have turned off the mic. So we'll start with the get weather. Let me switch it on. Weather of Delhi. As you can see, it is acting. It's calling the get weather from to getting the weather for Delhi. Like it is all hosh posh right now. But we'll solve it later. Just using get weather and called it, and it has fetched the thing about Delhi's weather, whatever it is. I will test out deep, deep research. Research about Dubai development. So it is now researching about Dubai development. So what tool it's using? It is using probably a deep research. We told it, no? Key research about. So we have explicitly mentioned it in RealtimeSTT that for things like that, use this to gather facts and write a deep report or when asked. So get my point. Let's now try screenshot wala too. We can also save this thing, no? Like we can say two things like call this and that. Like it's search about Dubai's development and save it to a file, something like that. Now it is hitting rate limit. So we'll have to wait. Note that I have a meeting at 7 a.m. tomorrow. So you can see like it is noting it down in the Math3 notes.md. So meeting at 7 a.m. tomorrow, and we can probably use something like summarize tools to summarize this Math3 notes wala thing. Write a poem about Narendra Modi and save it to pm.md. We'll try to do it. We can see it here. It knows nothing, no? Oh yeah, called create agent file and nothing else. Knows nothing about Narendra Modi. Probably should have called the search thing and should have got some context from here to write a poem. It's a limited model we have right now. So a limited reasoning model and limited context model we have right now. Limited data. It was trained on. Let us try something else. Like write a poem about love and save it to love.md. Should have called love.md. I don't know what's going on. Like that's why I told you, like it is still messy. I'll have to figure it out to make it good. Yeah, it is created the file. It's slow too. Yeah. We can try something else, like write a Python script about something. So you can see it has created the Python script.py file in hello world class. So you can see the capability of agents, like the OpenClaw thing, which is booming right now, trending. Let us just say edit love.md file. It's not limited to MD file. We can create any file. Let's say YAML file. Create a YAML file. So it created a YAML file, but Tokyo travel notes YAML file, because we're using storing all the conversation history, so it is like getting hallucinated. Like let me show you a screenshot. Let me show you again. Like I don't know if I have showed you a screenshot all the thing. Take a screenshot. Should have. I don't know what is happening. The thing I told you, like it's still messy, and I have to figure it out, like how I'll make it better. Take a screenshot. Yeah, now let's capture the screenshot. You can see it here. So you get the idea, like how it works under the hood, like how all these big companies are doing it, like at a grand level. Write a poem about two wandering birds and save it to wanderingbirds.md. So it still needs some refinement. Yeah, it has created the wandering birds. Imagine the possibility what we can do with it. The latency is very high, like it's taking very much time. After about 30 seconds writing this now, it should be taking that much time, I guess. I should move it to UI, like showing UI, some kind of UI, like to be able to know like it's working on that thing. Like right now I have no idea like if it's working on that thing or listening to some other thing that I'm saying. I'll probably fix that too and We'll show it in the last video or whatever video or another video to make it good, very good. So yeah, I'll polish this agent and add more tools. And even I told like hook it to social media APIs and all. And I'll push the code to GitHub for you to take a look. Maybe do something of your own. So yeah, you can check out my GitHub page and follow me there. So yeah, this is day 24. See you in the next video. Let's do it.